Okay, well, thank you very much for the to the organizers for inviting us to speak at this workshop. It's true that my co-authors and I are all from Hannover, Germany, but unfortunately, I am actually currently based in the US. And I'm mentioning this in part because it means that I was not able to attend this morning's talks. I want to apologize to the speakers who spoke this morning, and I'm truly sorry that I missed your talks. The paper I will present here today is a work in progress that was co-authored with the two other colleagues that you have already introduced, so I'm going to kind of skip over that and just kind of go straight to our actual talk. As you mentioned, one of us is a sociologist of science, two of us are philosophers of science, and so it's actually going to be kind of a mix between philosophical and sociological perspectives. And given that I'm the one presenting it, there's maybe going to be a little more philosophy, so I apologize. One widespread response to the replication crisis has been to call for more transparency in the scientific process, ranging from pre-registered studies to changes in review and publication policies. Such reforms are mostly geared towards preventing p-hacking, i.e. the questionable practice of inflating the statistical significance of a result by manipulating the data in various ways, or the practice of reinterpreting the data in the light of a post hoc hypothesis. The recommendations to share data in public repositories and, one recommendation is to share data in public repositories and to pre-register studies, and those recommendations are designed to make such practices, such as p-hacking, more difficult. While we believe these suggestions to be valuable and important, this talk will draw attention to an unquestioned assumption in the discussion about data sharing, namely that there is an unproblematic sense in which data are simply given, thus being available to be analyzed and or shared. By contrast, we wish to highlight that scientific data are manufactured and prepared for analysis by scientists under specific material conditions, with specific research questions in mind, and drawing on a set of skills or personal capacities that are, for all practical purposes, not always easy to explicitly account for and communicate, or to delegate to outsiders not directly involved in the respective research. So this means that when using someone else's data, there's always going to be an ineliminable element of trust. We will show that when researchers talk about sharing data, they typically have in mind primary data, raising questions about how such data are constructed on the basis of the raw data generated in experiments. In this talk, we will argue that the transition is characterized by an element of subjectivity and context specificity that may well contribute to replication failures, but that ultimately cannot, and more importantly, should not be completely eliminated. While this may seem to open the door to replicability problems, we will argue that there is no purely mechanical solution to these problems. We conclude with some suggestions on how these problems might be fruitfully addressed. So in my talk today, I will begin by introducing the notion of data editing, highlighting the elements of skill and tacit knowledge required for this. This will prompt me to remark on the fact that when researchers accept other researchers' data, they have to presume that the person who prepared these data possesses the requisite skills. We will situate this point both in the context of recent work in the philosophy of data and in the context of the social epistemology of trust, and conclude by arguing that discussions about the regulation of the scientific process need to be supplemented with discussions of that kind of skillful element and the trust that comes with it, or the need for trust. So let me start by talking about data editing. In a position paper by the German Research Foundation, the DFG, authored by a number of German psychologists, the authors laid out guidelines for what they call data management In it, they define, among other things, the meaning of the expression primary data as the, I quote, completely unaltered, i.e. not transformed, aggregated, etc., quantitative and qualitative data. They distinguish such primary data from raw data, i.e., and I quote again, the original record, for instance, check marks on a paper questionnaire, drawings, or audio and video recordings. They continue to argue that, quote, primary data should be made available digitally in a trustworthy repository. These brief quotes should make it clear that when we're talking about data sharing, we are talking about primary data, not raw data. This implies that completely unaltered should be taken with a grain of salt. At the very least, features of the raw data that are deemed irrelevant will have been eliminated. And hence, in order to arrive at primary data, the raw data set needs to be altered in some sense. Such alterations may involve coding answers, for example, by turning a yes into a 1, but it can also involve eliminating data noise or random outliers. Following an author by the name of Aaron Leahy, who I'm going to introduce in a moment a little with a picture, among other things, we refer to the transformation from raw data to primary data as one of data editing. And we argue that data editing is frequently more involved than the above cited guidelines might suggest. According to Leahy, quote, data editing occurs when a researcher adds, drops, or changes variables, values, or cases. Examples include changing a seemingly illogical value, dropping a few outlying cases, or choosing among alternative measures. And I'll just kind of throw in a couple of quotes from interviews that were conducted by one of us, Eva Barlösius, that kind of reinforce that kind of general sense. And I'll be giving you a more interview data later. So for example, one of the psychologists that were interviewed said, so there's data preparation. There are the raw data, which contain parts that are not necessary for the analysis. Those get prepared, transformed into a format that one can do analyses on. And somebody else said, statistics always relies on prepared data. So when I have raw data, I have to prepare them quite a bit. So let me be clear that data editing in and of itself does not constitute a questionable research practice. However, the crucial point is that deciding how to deal with illogical values or deciding that a specific raw data point is an outlier requires a judgment call. Such judgment calls can be well-founded, but the point is that once the process of data editing is complete, that judgment call itself has been rendered invisible, at least in the raw data and in the primary data. The connection to replication should be immediately obvious. It's entirely possible that two scientists might come to conflicting results depending on how they exercise their judgment in the process of data editing. It is also possible that two groups of scientists who use the same set of primary data to arrive at the same results, and yet it is possible for that to be the case, and yet for the results to be flawed, given some possible flaw in the data editing process. This raises questions about the nature and reliability of the judgment calls that assist the data editing process. And so in the following, we will explore the thesis that such judgments require what is sometimes referred to as tacit knowledge, i.e. some skills that cannot be, or at any rate typically are not, explicated. In the history of 20th century ideas, the notion of skills or tacit knowledge was prominently articulated by Michael Polanyi, who argued that science is operated by the skill of the scientist. Science is operated by the skill of the scientist, and it is through the exercise of the skill that he shapes his scientific knowledge. This was a quote. Polanyi goes on to remark that, and I quote again, the aim of a skillful performance is achieved by the observance of a set of rules, which are not known as such to the person following them. We believe that Polanyi puts his finger on an important feature of scientific practice, namely the fact that practitioners rely on hunches that while in Polanyi's words deeply personal and subjective, are also embedded in disciplinary traditions in hands-on training with the tools and method of a discipline at a given point in time. This, of course, was also remarked on by Thomas Kuhn, who saw tacit knowledge as part of the package that is acquired as scientists are enculturated into specific paradigms. Not only, Kuhn argued, are the rules embodied in the paradigm not necessarily explicit, but, I quote, indeed, the existence of a paradigm need not even imply that any full set of rules exists. This suggestion is important for our purposes as it highlights, once again, that even within the socio-cognitive context of a paradigm or of paradigm-guided research, there is room and need for individual judgments about the right course of action, where these judgments are constrained but not fully determined by cognitive and methodological features of research practices. Our thesis then is that such individual judgments play out in processes of data editing, though we stress that these judgments are determined by research context and hence are not arbitrary. So we want to be completely clear about that. We're not saying it's arbitrary and completely kind of subjective. Now, when I use the term knowledge, I think I want to just briefly add a clarification and say that the word knowledge might be a little misleading because it perhaps falsely implies that the scientific judgments in question cannot go wrong. We do not need to assert this. At the same time, however, we believe that the term knowledge rightly highlights what was, at least until recently, a widespread attitude towards scientists, namely that years of practice and experience make it justified for us to defer to their expertise. This not only describes an attitude that many lay people to scientific experts, but also characterizes a division of labor amongst scientists working on the same research question. This division of labor requires a certain degree of trust among researchers working together on a research question. But as we will see in a moment, such trust also plays a role in the review process, where referees typically do not see the raw data and have to accept the primary data where they're provided on trust. One thing that we can perhaps say about the current crisis of confidence, and of which, of course, the replication crisis is a part, is that precisely this trust has been severely undermined in recent years, leading members of both the scholarly community and the general public to ask whether more oversight is needed. One obvious place to turn to is the role of so-called gatekeepers in formulating and enforcing scientific standards. With regard to the question of this talk, this raises the issue of what the scientific standards of data editing are or ought to be and what it might take to regulate them. This question was addressed by the sociologist Aaron Leahy, who I already mentioned earlier, who remarked on the fact that, I quote, data editing is relatively invisible to those outside the research team, especially gatekeepers. Leahy conducted qualitative interviews with representatives of 3 groups of gatekeepers, journal editors, program officers, and IRB chairs, in order to determine how they viewed the data editing process, and in particular, whether it was realistic and advisable to put oversight mechanisms in place to regulate this process. Interestingly, she found that while some gatekeepers thought that the difficulties of overseeing data editing might be overcome by imposing standards, most of the gatekeepers she interviewed opposed this, worrying about, I quote, the ossification of standards and how a proliferation of standards might cripple research. According to Leahy, the main reasons given for this assessment are that research is contextual and contingent, which makes it very hard to formulate, kind of general, acontextual, and universal rules. And secondly, that gatekeepers trust scientists to make sound, reasonable judgments. Now, of course, this was kind of before the replication crisis really got going. So in the following, I want to unpack the reasons for those two assessments a little bit, starting with the question of what is the relevance of the contextual and contingent nature of research. our answer, or our main point, is going to be that it is the contextual and contingent nature of research that makes it unlikely that any two situations are ever the same. And this means that even when there are methodological guidelines on how to edit raw data, it requires some local and context-specific expertise to apply those guidelines to the specifics of a given case. It is the nature of local and context-specific expertise that is not easily shared, and therefore the need for trust. So let me start with a paper I like very much, and so I always like to quote it. Bogan and Woodward, in their 1988 paper, Saving the Phenomena, kind of introduced the idea of the locality and context specificity of data. Now, of course, it might be argued that it is precisely because of the locality and context specificity of data that regulation is needed. But as I just showed, gatekeepers at least 10 years ago seemed to think that it is because of this local and context specific nature of data that it's very hard to regulate the editing process. So we want to offer two arguments for why the context specificity cannot be completely eliminated. And we focus specifically on experimentally produced data to make two general points. One is that data are idiosyncratic to particular experimental context, and the other is that evidence is always relational. Now, with respect to the first point, it really should be, so for the point about the locality and context specificity, Bogan and Woodward made a similar point in their paper from 1988, where they said data are, as we shall say, idiosyncratic to particular experimental contexts and typically cannot occur outside of those contexts. And so they say this in the context of contrasting kind of the local context-specific data with the phenomena, which is ultimately what we want to say something about with our scientific research. So we argue that it follows that the production and handling of data requires a high level of experience, requires being immersed in the details of research, and cannot be done by outsiders or by some kind of abstract, by applying some abstract universal standards. There are two reasons for this. The first has to do with the material and physical skills of producing data, and the second has to do with the cognitive skills that are needed to determine whether an experiment has succeeded in producing good data. So just kind of briefly, I'm going to wave my hands at this. Of course, the notion of material physical skills, being able to see the right kind of things, being able to handle instruments, was made by Russell and Norwood Hansen, but also by Ian Hacking in his book Representing and Intervening. I've also pointed out in a public publication that it takes a kind of cognitive conceptual skill to make judgments as to whether the data in fact speak to the question of interest. And this gets me to, I want to explain this kind of in more general terms by turning to a theory of data that was kind of articulated by Sabina Leonelli recently, the relational theory of data. She emphasizes that data reflect scientists' interests, background knowledge, location, instrument, and research strategies. In agreement with this, our interviewees, and I'll get to a few more quotes in a moment, point out that working with the data presupposes a wide range of contextual knowledge about the apparatus, about the paradigm that informs the experiment, and about what exactly happened during its execution. Leonelli's point is, I quote, that it is meaningless to ask what objects count as data in the abstract because data are defined in terms of their function within specific processes of inquiry rather than in terms of intrinsic properties. Building on this and other arguments, Stefano Canali has recently argued that or proposed what he calls a contextual notion of data quality. That is, in order to argue that the data kind of do their job well, we need to know a lot about what there's, what the epistemic function is that they're supposed to be put in use for. So our point is that when researchers engage in data editing, they will inevitably draw on assumptions about the intended epistemic functions of the data that they're trying to generate. And also, I think more generally, in designing experiments, they're already making conceptual assumptions about what the data are going to mean. So let me just give you maybe, let me see how much time I have left. So I'll just kind of rush you through a few of our quotes where I think some of the people that were interviewed by us seem to highlight some of the things that I just said regarding the kind of context-specific local knowledge and the expertise that is needed to produce, edit, and interpret data. So here's one of the psychologists saying, well, you know, if my graduate student did it, who obviously is less experienced, I'd be reluctant to delegate data editing. I would want to do it myself. I would want to take a look at it. Somebody else said, so that raw data, if I gave you such a file, even if you knew what software it is and could somehow perhaps use it, that's pretty special. You probably would have a really hard time ultimately figuring out, actually I can't really see my screen here very well, so figuring out what the data mean. Somebody else says, can anyone but myself understand this? So understand how to proceed with the raw data, basically, is what they're saying. And here we have another scientist saying, well, once we've edited the data, the information, and you're looking for the information that's been edited out, well, the information wouldn't be there anymore. And another psychologist kind of points to that, gives examples. So, for example, let's say they looked out the window and we exclude that person. That's what I'm talking about. Well, sorry, and so this psychologist is saying, so I'd be talking about this with the researchers I'm working with, but not with people that aren't directly involved in the project, because they wouldn't be able to judge whether it's appropriate in such a case to eliminate the data. Okay, so just to kind of get to the general point, data are generated and edited for a purpose. Thank you. By the time data are ready for quantitative analysis, they've already been vetted. And to trust the data means to trust that the researchers who generated and edited them, in fact, had the requisite physical, material, and cognitive conceptual skills. And with that, I want to maybe sum up the point of the previous, of the talk thus far, to say that because of this, because of this, a certain element of trust is necessary, and this is why I want to now turn to some literature in the social epistemology of trust that we're bringing to bear on this. It's clear that the trust we might have to place, or that we have to place in the researcher's task with data editing, is not necessarily justified. With that said, we briefly nonetheless want to highlight some of the arguments from the literature in social epistemology as to why the need for an element of trust cannot be eliminated from the scientific process, and why deciding what's the appropriate level of trust in any case involves a set of complex trade-offs. Our basic point here is that while it is important to think about measures by which trust can be regained, these measures cannot rely on eliminating the human element of research altogether. John Hardwick, in a paper from 1991, has argued that scientists' long-term self-interest is not sufficient to avert fraud or scientific misconduct, and that therefore scientists are inevitably dependent on each other's goodwill and commitment to good practice, and thus need to invest trust in a moral sense. Hardwick's case for the inevitability of trust within science has more recently been complemented by other considerations. Thus, it has been argued that the research process is shot through with big and small choices that each require trade-offs between equally legitimate epistemic objectives, such as productivity of research, avoiding false positives, and avoiding false negatives. And of course, I'm thinking of Heather Douglas's work here. It's neither possible to make all these choices explicit in a transparent way, nor to regulate them all by means of standards. It will usually have to be taken on trust that other scientists have made such choices in an appropriate way. One of my co-authors, Torsten Wilholt, has made this point in print. In relation to data editing, we suggested in this paper or in this talk, and our interview sources have also maintained this, that rendering the process transparent by making it fully explicit in all its steps is as much a practical impossibility as delegating it to outsiders not involved in the research would be. If this is right, then data editing provides another case in point to complement and expand Hardwick's argument for the indispensability of trust for the collective epistemic enterprise of science. And just to continue this a little, it's been pointed out that trust is a kind of reliance that requires granting the trusted party discretionary power over the course of action that they're trusted with. Now, of course, I mean, the reason we're all here is because, as we all know, this trust has been disappointed. And researchers are struggling with concerns over replicability, and there's arguably problems of disappointed trust out there right now. The multiple reactions that propose to come to terms with this by ultimately substituting trust with control may offer partial constructive solutions, but if a residual element of trust is unavoidable on principled grounds, they're bound to ultimately prove insufficient. So once again, quoting Hardwick, institutional reforms of science may diminish but cannot obviate the need for reliance upon the character of testifiers. There are no people-proof institutions. So if lost trust cannot be completely substituted by control, it will have to be regained. This may require recalibration. The indispensability of trust does not mean that it is set in stone how much and how far scientists trust each other and in which respects. So let me conclude. In this talk, we've argued that scientific practice is local and context specific, thereby requiring local and context specific skills and cognitive judgments that are frequently not easy to explicate, making their execution hard to regulate, and thus highlighting the importance of trust in science. We focused on one specific area of scientific activities that we think is pertinent to the replication crisis, but that hasn't received much attention, namely that of data editing, though I did actually see that several talks in this workshop mentioned the problem with raw data. So I'm very excited to see that other people are thinking about this. Our main claim with respect to the practice of data editing is that it's local and context dependent in two respects, each of which often make it necessary to rely on the judgment of the researchers involved. So, of course, we don't believe this to be the end of the story. The current crisis of confidence obviously highlights the need to discuss how trustworthy scientific skills and inferences really are. We hope to have made the case that this discussion should not take the notion of scientific data for granted, but rather take a closer look at the material and conceptual assumptions ingrained in processes of data editing. So I'm actually trying to quickly wrap up here. That's why I'm hesitating how much I can skip. So I think that the point basically is, of course, not to kind of blindly trust in everything scientists do, but to pay more attention to questions. Well, not so much on kind of purely formal measures of instituting control or regulating, but to pay more attention to the material to the content of the questions that are actually being investigated, and on the assumptions that are kind of tacitly made by scientists in working on these questions. So our argument is not that researchers should place, or that we should place blind trust in data editing practices, but rather that there are no purely formal ways in which such practices can be regulated. And then an overly strong focus on formal mechanisms of distrust is likely to hamper a genuinely productive scientific exchange. Thank you.